Hi everyone, my name is Minut Mihai and today I will represent the team displayed here from the Faculty of Computer Science from Iași, Romania, and I will present to you our project Social Media Post-Impact Prediction using computer vision and natural language processing. Um, I will go through a variety of topics. I will first describe the problem, I will present how we approached it and our results, and then I will present what we could work on in the future and also our conclusions. Problem description. Introduction. The whole idea of the project was to make the end user, be able to predict what their posts on social media would get in terms of impact, likes, or whatever the associated platform has as a measurement. We would create an application for the end users, and the users will use it to make social media post predictions. In the process, we will create a model that will predict the impact, experiment with hybrid deep learning models, and also measure and evaluate the application as a whole. Other applications that we have found have applications in e-commerce and also social media posts. The e-commerce application was as well based on a hybrid model consisting in images and text, and it has proven results that state that the hybrid model was better than the sole image model or the sole text model. The social media application was described as detecting if a posting was offensive or not based on its text or image, and it also used an approach hybrid architecture where it would also take into consideration the image but also the text. The difficulties of such tasks conclude in very complex service architecture that needs to incorporate model updates and how they adapt based on the social media trends that are going currently on. The data sources, as you can imagine, are very scarce for this task, and the other difficulties are associated with the model. Training a hybrid model is taking a lot of time. It is much more complex in terms of data processing because it also needs to process images and text. And the testing and validation phase for such a model can take quite long because it is difficult to say how and when the architecture would be better in a hybrid case. Our approaches. The proposed solution. We initially wanted to make a model that would only take the text into consideration, but considering our initial results with only utilizing the text, we decided to go with a hybrid approach. The end architecture that we have is displayed right here. We have UI for the user, a web application displayed for the user, in which he could make all the actions that I've already presented. This is operated in the back with an orchestration service that basically operates as a gateway to the other microservices, and those are the account management service that holds the account data, the prediction management service that holds the historical predictions from one's account, and the prediction service that holds the model and basically serves to the user through the app the prediction. The dataset that we collected consists in a series of steps. The first one being parsing through the Twitter API for data. This was done daily for like 2 to 3 months. We gathered a lot of data from the posts field, and we selected the posts with the use of a word dictionary for different fields like nature, traveling, or other fields. We had like 20 to 24 fields in total. We imported the data locally by saving it as metadata text and an image link because we didn't want to take the image into account earlier. And by the end of the process, we ended up importing the images also, and also filtering the text and images to only get the suitable data. The model was, as I've already mentioned, a hybrid one. It took into consideration the text and the image. We had an NLP model and a computer vision model inside the whole hybrid model. The text processing part was done with the help of a fine-tuned BERT classifier, and the image part was done with the ResNet 18 fine-tuned model on our data. We chose those architectures because they were quite they are quite optimal, let's say, for our approach, and we also had data related to them that they worked in hybrid approach. The main use case that we had in mind was for the user to give us a text or an image, and through the model to fetch a prediction that would look like the one here. We would have a lot of classes of impact, and the model would try to predict the class of impact that the combination resides in. For example, this image resides in the 3 to 17,000 likes range. Our results. The application. Not only we implemented the normal use case, the one I have presented like 2 slides above, we've also managed to provide the user with the following feature of inputting more images and more texts, and the model would go through each combinations of those images and texts and provide the user with the best combination. And if more images would be on the same level, the first one found would be displayed. The dataset in the end consisted in 120,000 tweets. The text counterpart was averaged at 18 words, and images had a high dimensionality, as you can see here, concluding into 250 gigabytes of space and 3 days of import approximately, because of mainly the images. The dimension standard, as you can see here, was to choose one dimension to scale from 512 to 16 pixels. Basically, we went from 512 to 256 to 128 and so on until 16 for the height, I'm quite sure. And the other dimension was properly scaled with the height to not lose the dimensionality ratio and to also preserve the data. The data in the end was also padded with some white borders to again respect the initial ratio of the image. In the end, our models achieved an average of 10% accuracy scores on the taste data set. This is close to taking a random guess, since we had like 13 classes for prediction. It could totally be higher. Further models could be trained and tested on more variations of the dataset, including lower features and maybe more complex architectures and more complex bindings between the text and image model. Future work. For application architecture, we could also adapt the architecture to collect the data from users and use it for model training. We could also collect here the users input and what they do in the application to provide some measurements and see where the problems are in the UI. We could allow the user to select from the best predictions combination, not only return the best one. We could provide the user with a post-prediction history to see for the user to see what he has done in the past. We could also improve the infrastructure for efficiency and stability. For the dataset and model, we could train the model on different data formats and different sizes for images and also for text. We could train on multiple formats for the data, and we could also train for much longer times. Since for this task, training in a short amount of time is not producing very good results. We could also come up with new techniques for each part of the model, the text, image, and also the combination between the two to find a better end architecture. And we could, as I've already mentioned, test on more image standards and text embedding sizes. Our conclusions. We built a social media post impact prediction application. We had it deployed and the infrastructure was working well, as well as all the microservices. The target for our platform was Twitter, and it is also worth mentioning that it is also integrable with Twitter. You can connect on our application with Twitter with a Twitter account. The application can be accessed via web client, and the model that we achieved in the end, that we have built in the end, only had 10% accuracy, but it is utilizing both the images and text as an input from the user. And the data set is another result. The 120k tweets that reside in our dataset and have multiple data types, formats, and standards. This is the first reference page for the presentation. The second one. Thank you for your attention.